Hello, hello, everybody. Good morning. Good morning. Happy Tuesday morning. I had to think again. I had to think. I had to think again. I had to say, wait a minute, is it Tuesday or is it Monday? What? No, it's Tuesday, everybody. Happy Halloween. What? Happy Halloween. So the year is passing by so fast. What? Yes. So I'm on my cell phone. Yes, I'm on my cell phone. So I said, let me start doing my videos on my cell phone because I have been doing my videos from my desktop computer, and I noticed that the sound bounces in and out. I said, wait a minute now, is this the memory on this computer? Is this computer going bad, or what in the world is going on? So now I find that my videos are sounding better from my iPhone. So this is the iPhone 12 that I'm on. So it's an older iPhone model. Yes, so and I do have the iPhone 14, but I'm using the iPhone 12. But they come out with these iPhones so fast, What? Oh, glad you could be here. Glad to see you. Glad you all can join me. Subscribe to the channel. Yes. Hit the like button. Hit that like button, comment below, subscribe below. I mean, wherever you see the word subscribe. What? Yes. So wherever you see the word subscribe, then subscribe to the channel. I want to bring you business topics, anything related to business, marketing, branding, advertising, promoting, talking about individual brands. I talked about brands like KFC, Kentucky Fried Chicken. That's a fast food brand. You get your famous fried chicken with all those good seasonings and spices. KFC, Mr. Colonel Sanders started his business, I think it was back in, I have to go back to my research, so I did do a video. I think it's 1936, if I'm not mistaken. So he started just giving out chicken before he even started selling it in the area, giving out chicken with all those uh, seasonings, spices and seasoning, whichever way you want to put it. So he started out giving it away. I guess that was a good strategy because I want to give it out first and let people taste it and see if I should go forward with this brand. Yes. So KFC, Kentucky Fried Chicken. The brand is still around. Imagine 1936, and the brand is still around today. Yes. So Mr. Conrad, I mean not Mr. Conrad, or Mr. Colonel Sanders is not around today, but so the brand is still going on. Kentucky Fried Chicken. The brand lives on. Yes. And also, I was just saying something about Mr. Conrad. Yes, Mr. Conrad Hilton. So I also researched him as well when he started his brand of Hilton Hotels. So we know his granddaughter, Paris Hilton, and her sister, and then their mom, her mom, her mom, excuse me, her mom and dad. So, and also Paris has a whole lot of brands of her own that she has started. I know it's over probably 100 or some brands that she does have. So I will probably shed some light on her brands on my channel as well, because she has so many. And I might have touched base on some of her brands in one of my videos. I'm quite sure I did, but I probably will go back into her brands more, you know, so I can shed more light to all the brands that she does have. So she has a lot of brands. She definitely has a lot of brands, and I am going to probably shed some more light on all of her brands, little by little. So, like I said, when it comes to business, there is so much content that you can bring to your channel that relates to business. Yes, it's just so much. So many brands, so many brands. We have legendary brands. We have brands that are in the present, that we shop at now. Some brands started years ago, in the 20s and the 30s, and they are still they are still, out here today. So we can, purchase from them. So just imagine you start a brand, uh, company, just imagine some companies, have started brands in the 20s, 1920s, 1930s, and still around. So those are what you call the memorable brands, trustworthy brands, memorable brands, brands that you can trust, brands that offer value, brands that definitely memorable. So I mean, how can you not remember a brand that started in 1936? KFC. And we also have, that's a Kentucky Fried Chicken. That's a fast food brand. Then we have the retail brands. We have Walmart. When did Walmart start? I did research on Walmart too. I forgot what year they actually started, but we have Walmart. We have Kmart. We have the Nike brand, the Jordan brand. Nike and Jordan. They work together. So Jordan partnered with Nike. So how long has the Jordan and the Nike brand been around? So those are legendary brands. I call those legendary brands. So we have a Nike, we have we have Nike, Adidas, K Swiss, Reebok. All those are legendary brands that have been around what for so long. So I want to say welcome again, welcome to Brainstorm TV World Productions. So Brainstorm TV One Productions. Glad to see you. Glad you could be here. Glad you can join me. Yes. So I don't see anybody. What? I don't see anybody joining me, but I just be talking on it. So today I want to talk about deep learning, deep learning and machine learning. So I want to get into that. And then I'll probably, I think on my other video, I think I must have deleted it because I did it on my computer and my sound was bouncing in and out. So I probably will continue to do my videos on this cell phone because I did a video on the blockchain technology. So I did a video on the blockchain technology, and so it looks like I'm gonna have to do that video over as well. What? Yes. So Brainstorm TV One Productions. So let me get started on deep learning and machine learning. Let's see what that is about. So and also I did a video on artificial intelligence. So I don't know if I must have deleted that video too. So I will have to do some of these videos over. Or let me write that down. Artificial intelligence, deep learning, machine learning, blockchain technology. So I do have a list of. So excuse me a little bit, but nose a little stopped up this morning, but it's all right. I'm still here because I'm one of those people that I have to use a fan at night. I have to have a fan. I know I have ceiling fans all around the house. So sometimes I need to turn it down low because I do have to have, I like the air at night. I don't like to be all stuffy and hot. So, when you have the heat on, sometimes running the heat all night can, start, the house starts to get hot. So, so let me look over my list because I'm gonna have to do some of these videos over. So I have cloud computing, blockchain, the blockchain technology, machine learning. So I'm about to do that now, machine learning, deep learning. So I'm gonna have to go back and do cloud computing, blockchain, the blockchain technology, artificial intelligence. I may have to do that video over as well. Then I have e-commerce. Okay, I have a list. Big data analytics, predictive analytics. Then I also want to move into. Well, I did search engine optimization. I just did that this morning. Virtual and augmented reality videos on that I need to do. Then I want to move into cryptocurrency, Bitcoin. Just so many, So I have a list. So you have to write things down to keep a track of what's going on. What? Because you can lose track of your content. So I did purchase me several tablets so I can put, my information on paper. That way, the name of my videos that I want to, the titles of my videos, I guess I want to say it that way. What? Titles of my videos, I want to, make sure I have them down on paper so I can cover all the content that I need to cover. What? Yes. So, and I had to delete a few videos because they were bouncing in and out so much. And I said, no, I don't want that on my channel. So I am working from my cell phone this morning up early on this Halloween day, October the 31st. Oh, Hallows Eve. Oh, Hallows Eve. So I am working on my laptop early this morning. So let me, first of all, let me get only 12 minutes in. So I want to say thanks for being here. Glad to see you. Glad you could join me. I don't see anybody, but I'm moving on with my videos. I don't know why I don't have any interaction with people on my my videos. So I'm looking at all the buttons. I see the comments button, banners button, the brand button, and I see the mic, the camera, the guests, and more, but I don't see anywhere on this screen where it says you can have interactions with your viewers. So I don't see any of that. But, subscribe to the channel, like this video. So today I am going to talk about machine learning and deep learning. So what? Let's get into it, y'all. Yes, let's get into it. So let me go. Let's use some search engine optimization. Let's go to Google. So let's go to Google. What is deep learning? What is deep learning? I guess I would say versus machine learning. Machine learning is about computers being able to think and act with less human intervention. Deep learning is about computers learning to think using structures modeled on the human brain. Machine learning requires less computer power. Deep learning typically needs less ongoing human intervention. So in other words, machine learning requires less computer power. And deep learning typically needs less ongoing human intervention. So let's get into article. Let me get into an article. Deep learning versus machine learning. So when we're talking about these artificial intelligent machines that are being trained to think like a human, act like a human, be able to solve these problems, solve problems that humans usually solve. So they're trying to train these artificial intelligent machines, which are computers, It said, what is the difference between deep learning and machine learning? Machine learning means computers learning from data using algorithms to perform a task without being explicitly programmed. Deep learning uses a complex structure of algorithms modeled on the human brain. This enables the processing of unstructured data such as documents, images, and text. So machine learning, it means computers learning from data. So it's like a machine, a machine that is learning, a computer that's learning. See, machine learning means computers learning from the data, learning from the data using algorithms to perform a task without being explicitly programmed. And so we have deep learning that's using a complex structure of algorithms modeled on the human brain. So both of them uses these algorithms. So in other words, they're saying that deep learning uses a complex structure of algorithms modeled by, from the human brain. So in other words, they're looking at the human brain for this deep learning, looking at the human brain, so in other words, when it comes to our brains, I mean, I'm not a scientist or a doctor, but a lot of times we have a great memory device in our brain. In other words, to me, it's considered as a great memory device. In other words, like, say, for instance, you look at a picture one day or 1 minute, and you say, look, it's a picture of a person or a dog or a house or a car. And then the next hour, the next minute, or the next day, you still have that picture of that house, dog, or car in your memory. So that's how our brain works. Our brain memorizes everything that we see or hear or touch, all of our senses. So in other words, humans have these natural senses. Computers don't have any senses, so they can probably, be equipped with some artificial senses. But as humans, we have natural senses. We can hear, we can touch, we can feel, we can see, and all those things in our senses, helps us remember things etched in our brain, I guess I would say. So when we are talking about these artificial intelligent machines, a lot of companies are using. So I will do another video on artificial intelligence. So artificial intelligence, these artificial intelligent machines, computers, being trained to think like a human, act like a human, and take over some of the jobs that humans ordinarily do. What? Yeah. So I want to get more into that too, artificial intelligence. So to break it down in a single sentence, deep learning is a specialized subset of machine learning. In turn, is a subset of artificial intelligence. In other words, deep learning is machine learning. So machine learning, basically, I look at the term machine learning. Machines learning to do things that humans can do. Or sometimes they may be trained to do things that humans can't do. May be trained to do things that humans can't do. What is machine learning? Machine learning is the general term for when computers learn from data. So machine learning, computers are learning from data. So whatever you feed into those computers, which would be the input, you're going to get a certain output. So machine learning is the general term for when computers learn from data. It describes the intersection of computer science and statistics where algorithms are used to perform a specific task without being explicitly programmed. Instead, they recognize patterns in the data and make predictions once new data arrives. So I also want to talk about this predictive analytics, where these algorithms are, making predictions, through this, also that has a lot to do with this artificial intelligence. So I want to get into that probably on my next video. In general, the learning process of these algorithms can either be supervised or unsupervised, depending on the data being used to feed the algorithms. if you want to dive in a little bit deeper into the differences between supervised and unsupervised learning, now, in other words, you can read on. They said you can read through the article. I talked about that too in one of my other videos, supervised and unsupervised learning. So a traditional machine learning algorithm can be something as simple as linear regression. For instance, imagine you want to predict your income given your years of higher education. Excuse me. In the first step, you have to define a function, income equals y plus x times years of education. So income equals y plus x times years of education. Then give your algorithm a set of training data. This could be a simple table with data on some people's years of higher education and their associated income. It says, next, let your algorithm draw the line through an ordinary least squares regression, OLS. Now you can give the algorithm some test data, your personal years of higher education, and let it predict your income. So predictive analytics, predictions. So these algorithms on these different sites. Also, in other words, you go to a site and you may order this or that from Amazon, which, they use predictive analytics as well. So when you order from these different sites, and then when you go back on these sites to order again, they are making their predictions. They are making their predictions based on your past searches. You search for this, you search for that previously. Then when you go back, they were like, look, we have these recommendations for you. Or over here we have your browsing history. So a lot of sites are using this predictive analytics tool. It says machine learning is at the intersection of computer science and statistics through which computers receive the ability to learn without being explicitly programmed. There are two broad categories of machine learning problems, supervised and unsupervised. A machine learning algorithm can be something as simple as OLS regression. So let's get into it. What? Let's get into this deep learning, machine learning. So deep learning and machine learning. Deep learning is like, I guess they call it a subset of this machine learning. So in other words, deep learning, you're getting deep down into your learning process. What? Deep learning algorithms can be regarded both as a sophisticated and mathematically complex evaluation of machine learning algorithms. Deep learning, machine learning algorithms. The field has been getting lots of attention lately, and for good reason. Recent developments have led to results that were not thought to be possible before. Deep learning describes algorithms that analyze data with a logical structure similar to how a human would draw conclusions. So they're trying to make these deep learning machines. Deep learning, machine learning, these machines. So, they're not trying to make it like anything, but I guess, I don't know. It is, when you think about deep learning and machine learning, to me, these are just digital machines. Computers never will be, these computers, these digital machines would never be exactly like a human. They'll never be like a human. We are human beings. We can't think that these deep learning, machine learning machines, digital computers, I don't think they'll ever be like totally like a human. They can't think like us. They can't act like us. They don't have feelings like humans. We have feelings. We have senses. These are digital machines, computers. But, let me read on. So it is inspiring though. What? Thank you for being here, everybody, on this Tuesday morning. Halloween, Hallows Eve. What? So I like to look at a lot of little Chucky movies. Scream, Chucky. I've watched a lot of Scream movies too with the Wayans brothers. So I like those, and I love me some Chucky pictures. So I may watch some Chucky movies tonight. Deep learning describes algorithms that analyze data with a logical structure similar to how a human would draw conclusions. So, right, they want to make these deep learning machines, deep learning machines, um, deep learning, uh, these deep learning machines, computers. They want to make like they are, or they try to train them to think like a human, act like a human. You know, in other words, they can, do some of the jobs that humans usually do. So they have these deep learning machines, deep learning computers that they're training. So they want to train these computers, and sometimes some companies they are taking over and doing some of the jobs that the humans ordinarily do. And then, because to think about it, companies can save money. What? Companies can save money. They don't have to pay these machines, but they have to pay the humans. Look, we're going to put you out of this job. We have these deep learning machines that we have been training. We're teaching them. We're getting them involved in this algorithm. We're getting them involved with training them, feeding them certain data for input, certain inputs to come up with a certain output, and certain jobs that humans usually do. Some of these deep learning machines are doing, taking over. Deep learning describes algorithms that analyze data with a logical structure similar to how a human would draw conclusions. So they want to make, train these computers, train these digital machines to be able to come up with solutions, conclusions like they want them to be able to draw conclusions like humans would, like humans would do. As humans, we have to be thinking about, I'm like, you're trying to train a machine to do better than me, a human, things that I could do. You're trying to train a machine, a device, but don't want to sound negative, but I guess it's some positive in it. To achieve this, deep learning applications use a layered structure of algorithms called an artificial neural network. So deep learning applications, they use a structure of algorithms called an artificial neural network. That's called ANN. The design of such an ANN is inspired by the biological neural network of the human brain. So right, they try to mimic humans. They're trying to mimic our brains as humans and have these digital machines based on this deep learning, machine learning. So if they study out, well, I guess scientists have already studied the human brain. So if they figure, hey, we study the human brain, just like they study anything else. They do experiments on mice. Experiments on mice, and giving them certain medications to see how those medications will react on the mice. And then on then next thing you know, to the humans, but that's what they are doing with these artificial intelligent machines, deep learning, machine learning. They're trying to mimic the human brain. I guess if you study something long enough, you can find out how it works, how it functions. You can pretty much study anything over some period of time and see how it works. So they're trying to mimic the human brain. And to me, I don't, in my opinion only, I don't think computer, the computer, they do have their memory, they have the memory, the hard drive, but you have the human brain. We are humans, we are live beings. Those artificial intelligent machines, that's why they call it artificial intelligent machines, because they're artificial, they're not real. How you going to train a human, not a human, how you going to train an artificial intelligent machine to overpower a human, what a human can do? Come on now. The design of such an ANN is inspired by the biological neural network of the human brain. So you hear that? So the neural network, artificial neural network, ANN. So that's inspired by so that's why they said artificial. Artificial means not real. We are real. You don't hear nobody saying we're an artificial human. What? So let me move on. But I mean, it say consider the example ANN in the image above. Okay, I saw that there. Let me see this image. So this is the AN. I'm looking at the ANN, artificial neural network, ANN. We have the input, we have the hidden layer number one, we have the hidden layer number two, and we have the output layer. So it says the ANN is inspired by the biological neural network of the human brain. Human brain. Okay, let me go. Today, deep learning is used in many fields. In automated driving, for instance, deep learning is used to detect objects such as stop signs or pedestrians, right? Right. So in other words, that's what this comes up when I'm talking about what I was talking about previously, the senses. So it says deep learning is used in many fields in automated driving. So we have those self-driving cars, Tesla, and those self-driving cars, and also have the electric cars. For instance, deep learning is used to detect objects. In other words, deep learning, they have these artificial intelligent machines. They are equipping them with this deep learning. So they don't have sensors like we do as humans. So they have to equip them. Yes, what? It's so good. Equip them to detect when a pedestrian is walking across the street. You have these self-driving cars and you have these artificial intelligent uh, machines, technology, based on deep learning, machine learning, these self-driving cars. So what if somebody not, and what if, somebody's not, well, actually that's what it is, self-driving. You don't find nobody under the steering wheel. So what if a pedestrian walks across the street and, in other words, they're saying based on this deep learning, uh, they can sense, that a pedestrian is walking across the street and they will stop. But that is a definite risk because as humans, we have natural senses and we will know if we're driving our car. We can see actually. We see a pedestrian walk across the street. We'll see it. But they said that, this deep learning is used in many fields in automated driving, So in other words, deep learning allows these artificial intelligent machines, these deep learning machines too, I guess, these cars, these self-driving cars to know, when to stop, when to stop at a stop sign, when they see a pedestrian, when to detect, they can detect objects in the road, based on this deep learning. So these self-driving automated cars. So the cars driving by themselves. And they like they're gonna have somebody, you know, in these cars and they can, see a pedestrian. But I mean, so let me read on. The military uses deep learning to identify objects from satellites, to discover safe or unsafe zones for its troops. I mean, I guess it's a lot of positive, but there are going to be negatives. And it says, of course, the consumer electronics industry is full of deep learning. So the electronics industry full of deep learning. Home assistance devices such as Amazon, Alexa, for example, rely on deep learning algorithms to respond to your voice and know your preferences. So in other words, the Amazon devices, the Alexa, so that's based on deep learning. They respond to your voice. So I mean, I guess I mean, that's good. I mean, that's a good thing, though. That's a good thing. They can respond to your voice. That's what they are basing this Alexa on. I was always wondering how they, how that, how that went, how they, did those type of things. How did they create this Alexa and Siri and Alexa, But I wanted to get into this deep learning, machine learning, artificial intelligence. I wanted to get into it. How about a mere concrete example? Imagine the company Tesla. Tesla. I had to say that twice. Using a deep learning algorithm for its cars to recognize stop signs. In the first step, the ANN would identify the relevant properties to the stop sign, also called features. Features may be specific structures in the input image, such as points, edges, or objects, while a software engineer will have to select the relevant features in a more traditional machine learning algorithm. The ANN is capable of automatic feature engineering. The first hidden layer might learn how to detect edges. The next is how to differentiate colors. And the last, learn how to detect more complex shapes. Catered specifically to the shape of the object, we are trying to recognize. So say the first hidden layer might learn how to detect edges. The next is how to differentiate colors. So it's just like training these artificial intelligent machines, they're teaching them. And the last learn how to detect more complex shapes. Cater specifically to the shape of the object we are trying to recognize. When fed with training data, the deep learning algorithms would eventually learn from their own errors whether the prediction was good or whether it needs to adjust. So it's a learning process. In other words, you put the right information in these algorithms for this deep learning technology tool, I guess, for businesses. So if fed, in other words, they're saying if fed the right information, they can train these algorithms based on this deep learning. So in other words, and they can also learn from their errors, and they can learn whether the prediction was good or whether it needs to be adjusted. So predictive analytics, overall through automatic feature engineering and its self-learning capabilities, the deep learning algorithms need only little human intervention. So they're always going to need human intervention, like I was always saying. But they said needs the deep learning algorithms. Says overall through automatic features, engineering and its self-learning capabilities. The deep learning algorithms need only little human intervention. What? Wow, this shows the huge potential of deep learning. There are two main reasons why it has only recently attained so much usability: data availability and computer power. Firstly, deep learning requires incredibly vast amounts of data, right? So I also have a term that I want to do a video on called big data. I know Facebook uses big data. So big data, Facebook gathers a lot of data per minute, per second. So many users on Facebook, then even a whole lot of other, social media sites, TikTok, even YouTube. So big data, so much data. I mean, data has to be protected. Data has to be protected and secured because you don't want these hackers to get in. When those hackers get in and infiltrate your system, yes. So that's where also we have our, the blockchain technology that companies use. They are using this blockchain technology also to keep their information on the networks safe and secure. Information and data, whatever you want to call it, running across the block, creating this chain of information, keeping the information safe and secure. So I will do a video, get more into this blockchain technology. that the businesses are using. Secondly, deep learning needs substantial computer power. However, so you can unplug them, they won't work no more. So if the charge goes down, just think about that. But I mean, we can never you can never unplug a human, but you can unplug this deep learning machine. So that is the advantage that we have over those computers. What? So let the charge go down, let the battery go down, and they go right out. I mean, but humans get tired too, but we get tired, you have to lay down, we have to go to bed. What? Firstly, deep learning requires incredibly vast amounts of data. We will get to exceptions to that rule. Tesla's autonomous driving software, for instance, needs millions of images and video hours to function properly. Like I said, they'll never be able to be like a human. I mean, you can train them all you want, but when that battery go down, you down for the count. We don't run by batteries. No, we don't. We just need a little sleep, rest our bodies, and we're back up and moving and running again. What? Yes. Welcome, everyone. Welcome to all the new listeners. Welcome to listeners and viewers all over the world, international, global. Thanks for joining me. Yes. Brainstorm TV One Productions. Let's get back into it. This deep learning. Deep learning. So learn more about deep learning, machine learning, deep learning, artificial intelligence, the blockchain technology, big data, e-commerce, so many different terms that I will be covering on my channel. Okay, let's get back into it. However, with the emergence of cloud computing, infrastructure and high performance GPUs, graphic processing units used for faster calculations. What? Yes. The time for training a deep learning network could be reduced from weeks to hours. It can be reduced. The time for training a deep learning network. So in other words, you're training a deep learning network connections, sharing information. The network is geared towards passing on information, sharing information. But probably one of the most important advances in the field of deep learning is the emergence of transfer learning. What? See, these are some new terms. Transfer learning, the use of pre-trained models. The reason transfer learning can be regarded as a cure for the needs of large training data sets that were necessary for ANNs, artificial neural networks, ANNs, to produce meaningful results. So we have the transfer learning. So let me write that down. Oh, so it's just so many. Oh, wow. And then, those of you who are interested, you can also go on the Coursera website, and they have free courses now. So I did sign up for the artificial intelligence for everyone. I signed up for a machine learning course, a law class, and a business course. Even though I already have my degree, but I just want to enhance my knowledge and my skills. So Coursera. No, I think it's Coursera. I'll put it, I'll put it on one of my videos. I think I already put it on there though, but maybe I'll put it on my comments. Maybe I'll put it in one of my comments, in the comments section. So it's .org. I think it's COURSERA, something like that. Coursera, I think it's Coursera.org. So they have free courses. Then you can also get a certificate. They have courses that you can obtain a certificate. I think they cost just a little small fee, but so transfer learning. So I wrote that term down. The reason transfer learning can be regarded as a cure for the needs of large training data sets that were necessary for artificial neural networks, ANN, to produce meaningful results. These enormous data needs used to be the reason why ANN algorithms weren't considered to be the optimal solution to all problems in the past. However, for many applications, this need for data can now be satisfied by using pre-trained models in case you want to dig deeper. We recently published an article on transfer learning. So, in other words, I was reading about, I was just up here reading about these self-driving cars. They said sometimes they have to take, let me go back down here. Battery time run out. Automatic features, engineering, and its self-learning capabilities. The deep learning algorithms need only little human intervention. So they need only, the deep learning algorithms, they need only little human intervention. But firstly, deep learning requires incredibly vast amounts of data. So these could be some of the drawbacks of this deep learning. Firstly, deep learning requires incredibly vast amounts of data. Tesla's autonomous driving software, these self-driving cars that Tesla has created. What? Yes, thanks for joining me, everyone. Yes, Tesla's autonomous driving software, for instance, needs millions of images and video hours to function properly. That's what we want to know. So in other words, but I mean, it's a good step forward in technology. Tesla's autonomous driving software, for instance, needs millions of images and video hours to function properly. Yeah, so let me get me a little bit of water. My mouth is dry, so I've been talking for so long. But what? Yes, thanks for joining me. Thanks for joining me, and I'll be right back. All right, so yes. Okay, so in other words, Tesla with these, with those self-driving cars, they need, so they said they need, so Tesla, so no, firstly, okay, what did it say? Hold on. Firstly, deep learning requires incredibly vast amounts of data. So in other words, the deep learning, it's a good step. It's a good step up in technology, a step forward, I guess I would say. Technology is always, being created to be innovative and creative. So, I mean, we want to take a step forward. We don't want to take a step backwards. So, I mean, Tesla's autonomous driving software. So, in other words, it needs millions of images. So, in other words, battery. It takes a lot of battery hours. So there are two main reasons why it has only recently retained so much usability, data availability, and computing power. So when the computing power could run down, you have to charge, and then you think about these electric cars that Tesla created. So in other words, electric cars, I would assume, I don't know if they run by batteries, electric. No, they're not running by batteries, they are electric. So you have to, they had the little sites around town where you can charge it up, So I assume, I don't know if it's run by electric. Does it have, according to this, my research right here, it says the automatic overall overall through automatic feature engineering and its self-learning capabilities. The deep learning algorithms they only need little human intervention. And also deep learning, while it shows the huge potential of deep learning, there are two main reasons why it has only recently attained so much usability. So in other words, you have data availability and computing power. Then secondly, deep learning, it needs substantial computing power. It needs substantial computing power. So I assume that, right, that's either electricity or, I mean, if you want your computer to have power, we definitely have to plug our computers up to keep them charged up. So, but Tesla needs, Tesla's autonomous driving software, for instance, needs millions of images and video hours to function properly. So in other words, right, in other words, you're feeding the input to get a certain output. So so you're feeding these self-driving cars. You have, in other words, Tesla's autonomous driving software. They need millions of images. So in other words, putting millions of images and video hours into creating this autonomous driving software. In other words, the software has to have input of million images and input of a certain amount of video hours to work properly. So it's this, Tesla's autonomous driving software. So in other words, I read previously, when you have to feed these artificial intelligent machines certain information, certain data, so they can keep it in their memory. So it's the same thing with the human brain. Certain things we are fed would be considered, input. Certain things we are fed in our brains. I mean, we can see a movie. We can go look at a movie, go to the movies or watch a movie from our home, and then we're putting stuff into our memory. That's input. And then, then when you're talking to somebody, your friends or your family, you can tell just about everything that went on in that movie because it is in our memory. Go look at a movie. Even if you go to a website, even if you type an email, whatever you do, even if you're talking about something, and then that's all input. That's all information that is in that I would consider to be input in your brain, and it goes into your memory. And then, later on, you can recall, we can recall just about anything that we've seen or we've heard or we talked about, previously. That's input, so it's going to get a certain output. So to train these artificial intelligent machines, you're feeding them certain information, certain data, so they can come up with a certain output. And they are being used in some of these companies. They are being used, these deep learning machines, deep learning, machine learning, or these artificial intelligent machines that they call computers. Yes, so they are taking over some of the jobs that the humans usually do. But the deep learning needs substantial computing power. So that means you have to definitely keep these machines charged up. So like I said, they said it uses minimal human intervention, but you're gonna need a human. You're going to need a human to intervene to plug that machine up to keep it going, to have the large amount of computing power. So we don't have to do that as humans. So we have to think about those type of things. So in summing up, deep learning is a specialized subset of machine learning. Deep learning relies on a layered structure of algorithms called an artificial neural network, ANN. Deep learning has huge data needs, but requires little human intervention to function properly. Right. But if that machine doesn't have enough charge on it, who do you think will have to plug it in? Who do you think is going to have to plug it in, charge it up, make sure it can run properly? Transfer learning is a cure for the needs of large training data sets. So you can learn more about ANN versus CNN versus RNN. Artificial neural networks, ANN. So I think that is so I think that is the end of this article. Oh no, here was something else at the bottom. The main differences between machine learning and deep learning. So let's get to the end of this article. What? I'm already at 55 minutes. Oh, this is a common question. If you have read this far, you probably know by now that it should not be asked in that way. Deep learning algorithms are machine learning algorithms. So deep learning algorithms are machine learning algorithms. Therefore, it might be better to think about what makes deep learning special within the field of machine learning. The answer, the artificial neural network, ANN algorithm structure, the lower need for human intervention, and the larger data requirements. So they're saying that, when it comes to this deep learning or this artificial neural network is an algorithm structure, has a lower need for a human's intervention, but it has a larger data requirement. First and foremost, while traditional machine learning algorithms have a rather simple structure, such as linear regression or decision tree, deep learning is based on an artificial neural network, ANN. So deep learning is based on an artificial neural network. This multi-layered ANN is like a human brain, complex and intertwined. So in other words, when it comes to deep learning, they're saying that it's based on an ANN and it's layered like a human brain. So that's what they want to think, is layered like a human brain. I guess it's, they have been training these artificial intelligent machines, these artificial neural network, tools. I guess I would say deep learning. Based on deep learning, they want to let us know that, hey, they can mimic the human brain. Mimic the human brain, right? Keeping things. So in other words, inputting things into this computer's memory, they can remember things just like, when you put things in our brain. In other words, somebody tell us something, we go see something, we go see a movie, a play, and it's going to be etched in our memory. So that's what they're saying about the computer brain. The computer brain, the hard drive of a computer, things that you put in, is going to determine what you get out. The same thing with a human brain. Deep learning algorithms require much less human intervention. Deep learning algorithms require much less human intervention, but as I said, it's going to require some sort of human intervention. We might have to plug it in, so to charge it up, unless it runs, and if it runs by batteries, so I don't know any computers nowadays that run by batteries. Come on now, really? What? I don't know any computers that run by batteries. So you're talking about training these artificial intelligent machines. They have to be plugged up to keep charged up sometime or the other. Because I know I have a desktop, and I know I have a desktop and a laptop. I'm not training them to be artificial intelligent machines, but they are. They still, to me, are artificial intelligent machines, but they have to be plugged up sometime or the other to be charged up. I don't know any, like I said, I don't know any computers. I don't know. That would be something. Wouldn't there be something, the computers on the market that, run by batteries? I don't know. I mean, I'm talking about as far as the laptops and the desktop, I don't think any of those run by batteries. I mean, they do have the batteries in them, but I'm saying you still have to plug them up. but they do have a battery. I know my laptop does have a battery in it, but I still have to plug it up. I still have to plug it up, to charge the battery. So they run by battery, but you still have to charge the battery up. So that's what I'm saying. But secondly, deep learning algorithms require much less human intervention. Remember the Tesla example? If the stop sign image recognition was a more traditional machine learning algorithm, a software engineer would manually choose features and a classifier to sort images. Check whether the output is as required and adjust the algorithm if this is not the case. As a deep learning algorithm, however, the features are extracted automatically and the algorithm learns from its own errors. Machine learning, deep learning. So in other words, in machine learning, there's a little example here that I'm looking at as, your input. In other words, a car riding across the street will be, they're showing you that's the input. Then the feature extraction, then the classification, and then you come with the output. Then deep learning, you have the input, you have the feature extraction plus the classification. Then you have the output. Thirdly, deep learning requires much more data than a traditional machine learning algorithm to function properly. Machine learning works with 1,000 data points. Deep learning oftentimes only with millions. Due to the complex multi-layer structure, a deep learning system needs a large data set to eliminate fluctuations and make high-quality interpretations. Got it? But what about coding? Deep learning is still in its infancy in some areas, but its power is already enormous. It is mostly leveraged by large companies with vast financial and human resources. Since building deep learning algorithms used to be complex and expensive, but this is changing. We at Levity believe that everyone should be able to build his own custom deep learning solutions. Okay, it says if you know how to build a TensorFlow model and run it across several TPU instances in the cloud, I want to get into cloud computing too, probably in one of my videos. It said the blockchain technology businesses are using e-commerce, cloud computing. Like I said, we talked about deep learning, machine learning, so many different, technology tools that businesses are using to stay competitive, be able to compete, search engine optimization, being able to advertise your business products and services, being searchable on Google. So you can hire a expert in search engine optimization techniques, people with ideas about how artificial intelligence could be put to great use, but who lack time or skills to make it work on a technical level. I am not going to claim that I could do it within a reasonable amount of time. So this is the article I'm reading. Even though I claim to know a fair bit about programming, deep learning, and even deploying software in the cloud. So if this or any of the other articles made you hungry, just get in touch. We're looking for good use cases on a continuous basis, and we are happy to have a chat with you. So it says learn more about precision and recall in machine learning. So that is the end of the article. So there's deep learning versus machine. That's the name of the article, deep learning versus machine learning. So this is an updated article. This is by a gentleman named Arnie Wolfowitz, February the 15th, 2023. So to most people, the term deep learning and machine learning seem like interchangeable buzzwords in the artificial intelligence world. So I'm gonna close this video out now because it's been an hour and over 4 minutes. It says, however, that's not true. Here's everyone who seeks to better understand the field of artificial intelligence should begin by understanding the terms and their differences. The good news is not as difficult as some articles on the topic suggest. But I want to close out this video now. So if you want to learn more about deep learning, machine learning, you can also do some more research. But so stay tuned for my next video where I'll be talking about the blockchain technology. What? So the blockchain technology, with this technology tool that businesses are using to keep their information, data, network safe, secure from hackers. You can't get it through this blockchain technology because it is immutable. Yes, it's immutable. So I'm going to do that in my next video. So you all have a good one. Yes, and brainstorm everyone. Glad to see you. Glad you could join me. Glad you could be here. So subscribe to the channel, like this video. Yes, and Brainstorm TV1 and Brainstorm TV1 Productions. I don't want to forget that. What? Yes. So I hope you all have a nice Halloween. Don't eat too much candy. Don't eat too much candy. Yes. Keep an eye on your kids. Yes. Keep an eye on your kids while they are going out here trick-or-treating. I don't even know if they don't even trick-or-treat around this area too much no more. They used to, because I used to hear the little kids with their parents, knocking on my door. But, that was some years ago, 4 or 5 years ago. But I don't know if any kids are going to be trick or treating today. But so I guess they have to go to school first, So, and a lot of times now, parents, people are just having little parties and stuff at home, little Halloween parties at home to keep the kids from going, from not, going out into, the street and have to worry about going to different people's houses, because sometimes people are cruel. I mean, I know back in the day they be putting razors and apples. I'm like, what kind of people are these? Razor blades and apples and stuff like that. Why would somebody even do something like that? I know they were doing stuff like that back in the day, but I haven't heard anything like that happening recently. So I said that's a good thing. But hopefully everything goes well today. So I just want to say happy Halloween to everybody. October 31st, the last day of October. We're moving into November. Before it'll be Thanksgiving, then Christmas. So I hope you all have a nice holiday. So have a nice Halloween, have a nice Thanksgiving. Try not to eat too much. Try to eat healthy. Then we have Christmas coming up. Then we have New Year's. So try to eat healthy. I would try to eat healthy as well. I always do my fresh greens and pluck them yourself and you clean them, or you can do your string beans, pluck your string beans, clean them, put them on, season them down real good with whatever. And then I didn't cook a turkey last year because I try to stay away from a lot of meat. Trying to keep those calories down because it don't take long. So it does take long because sometimes my eyes are bigger than my stomach. You see that homemade macaroni and cheese. What? Get it together, girl. You see that homemade macaroni and cheese. You see those beautiful looking candy yams with the marshmallows on top. Then you see that stuffing. It smells so good. Yes. Then you get a hold of that potato salad, freshly homemade potato salad. But so I don't know what I'm gonna cook. So I didn't cook a whole lot last year. So I try to keep it simple, Just keep it simple, but you have to eat. You're gonna have to eat anyway, so. But whatever you want to cook, it just depends on how many people you want to have over your house. Some people going out. Some people may go out for dinner. Some people travel. A lot of people travel for Thanksgiving, for Christmas. They travel to their parents' house. Other relatives, and get on the plane, get on the train, go see. Because some people working all year, and They don't have time to travel. A lot of family members live out of town. What? Yes, so it's all good. A lot of family members live out of town, and that's the time that they take to go visit their family members because they're working all the time, or wherever they just home, or they just home. Some people work from home at the same time, so and they go and and say, hey, well, this is the time for us to travel. This is the time for us to hit the road, get on the plane. We have some relatives in California. We have some relatives out of the country. I mean, some people, the relatives in California. You might have somebody in Nigeria. What? Yes. So, it is what it is. So let me end this video because I want to do my next video. I want to get into this blockchain technology. So thanks for joining me. Glad to see you. Glad you could be here. Glad you could join me. So, Brainstorm TV, what? Yes, Brainstorm TV, what? So, we out.